Oh, there we go. Made the beep. Okay, ladies and gentlemen. Hello, grade 11s. How are you? It is Monday morning. I'm a little behind schedule this morning. Sorry about that. I'm going to make a video. Then you've got a pretty big assignment that's a review that's due later in the week. I can't remember exactly what day. It's on the website. But no video Wednesday, and I'll do a key on Friday's video. Okay, so let's get down to it. Here we are on page 118. And we've been doing stuff with quadratics, but we haven't really done anything with quadratics. We've been moving around, but I haven't shown you what you can do with them. So let's start with that right now. So a farmer wishes to enclose a garden with 100 meters of fencing. So dude only has 100 meters of fence. So no matter what, his garden, X, Y, because X and X are the same, and Y and Y are the same because it's a rectangle. 2 X's plus 2 Y's has to equal 100 because he's only got 100 meters of fencing. Let's factor that. X plus Y then has to equal 50. It cannot be any bigger than 50 because if he uses 50 here and here, he's only got 50 left for here and here. Okay, so this is what we're going to be working with. So if the garden is X meters wide, well then I know X plus Y has to equal 50, which means the length, which is Y must equal 50 minus X, and area of this rectangle is X times Y. Well, we know X is X, it's the width, and we know Y is 50 minus X. So the area of this garden is 50X minus X squared. And we know that. So that's what we are going to work with. So we got to find the width of the garden if it's got an area of 525. Okay, well that's not too hard. B, the area, we know area equals 50X minus X squared. Well, read the question. Area is 525. So 525 has to equal 50X minus X squared. And I want to find X. Well, all I got to do then is find the roots of this. But this is in a yucky state, so let's set it up nicer. X squared minus 50X plus 525 equals Y. And since I want to know what the X's are, that must mean I need the roots. And the roots exist when Y equals 0. Well, here I've got a trinomial, and it factors. You don't have to factor it. You could use the quadratic equation. You could find the vertex and do the stretch factors. You have all kinds of options, but this happens to factor to X minus 15 and X minus 35. So X has to be 15 or 35. So if we were to graph it, it would look something like, something like this, right? Because our A was positive. Yeah? So, let's go into C. I've already used black. Let's use blue. So C says find the maximum area of the garden. Well, the maximum of anything is the vertex, isn't it? So since we already know our roots, we know our vertex is halfway between them. So we know our vertex X has to be 15 plus 35 divided by 2, which equals 50 divided by 2, which equals 25. So I know that's my vertex. Now I could have found that in a lot of other ways. I could have done vertex X equals negative B over 2A, which would have gotten me 50 over 2 times 1. Again, 25. I could have completed the square and gotten, again, 25 if I did x minus 50x, x squared minus 50x plus, now remember I divide that by 2 and square it, plus 625 equals y. I brought the minus 525, but I added 625, so x minus 25 squared minus 100 equals y. There is my vertex x. Again, it's 25. So the vertex is 25, so it's always going to be 25. Now we know then if x equals 25 and area equals x equals 50x minus x squared, then the area equals 50 times 25 minus 25 squared, which is 625 meters squared. And that's done. Let's move on to 119. Now, here's our quadratic. Ooh, barfy. That's in a weird order, isn't it? So let's sort it out. First thing, before we even do that, I don't like that order. So I'm going to change it. H equals negative 4.9t squared plus 24t plus 1. Now, H is t's. What are you talking about, Myers? T time, there's your x. H is your y. And there's your A, there's your B, there's your C. So I want the maximum height of the ball. Well, isn't the max a vertex? Yes, of course it is. So if I can find the vertex here, I will know the maximum height of the ball. Now, finding the vertex usually means putting it into vertex form by completing the square. I don't want to complete the square because that is so ugly. I don't want to deal with a negative 4.9. So I'm going to use vertex x equals negative b over 2a. So that's negative 24 over 2 times negative 4.9, which is negative 24 over negative 9.8, which is, I got to get out my calculator because it's yucky. I don't want to do that in my head. 24 divided by 9.8. Now some of you will be saying, Myers, why are you putting the negatives? Because I don't need the negatives, because two negatives make a positive. And I get an answer of 2.448. So let's call that 2.4 seconds. So my vertex x is 2.4 seconds. Now, x equaled time. This question wants the height. Well, y equaled height. So what do I have to do with that x to find a height? I got to go back here where it says height equals negative 4.9 t squared. 2.4 squared plus 24 times 2.4 plus 1 to get my answer. And again, I have to go to my calculator. And I just punched in like I see it. Negative 4.9 bracket 2.4 close bracket squared plus 24 bracket 2.4 bracket plus 1 equals 30.376, so 30.4 meters. And we're done. Now, the next question is a little weird. For what length of time will the ball be higher than 20 meters? Well, if I were to graph this, it would look like this, right? There's my 20 meters right there, yeah? So I need to know this interval of time. I know my y value is 20, right? So, what am I going to do there? I'm going to pause it, let you think about it. Okay, so how am I going to do this? Well, I know my height needs to be 20, yeah? So, what if I did this? Oh, my battery's in my... I gotta go grab my cord. Give me a sec. I'll pause it. Hey guys, sorry I was gone so long. For you, it doesn't seem like I was gone at all, but if you look at the time, I was actually gone for quite a while. I couldn't find my cord anywhere. So anyway, where were we? We had this, right? But I want to know, for what length of time will the ball be higher than 20 meters? So my height is no longer y, it's 20. So 20 has to equal negative 4.9 t squared plus 24t plus 1. I can't deal with that because I got two numbers, but it's easy to fix. H equals negative 4.9t squared plus 24t. Bring that over, minus 19. Now all I need are the roots here, because now I'm going to be at my 20. So all I got to do is run this through the quadratic equation, A, B, C, which is negative 24 plus negative b plus or minus the square root of b squared, 24 squared, minus 4 times a, negative 4.9, times c, negative 19, all that over negative 2 times negative 4.9. And when you run that through your calculator, so remember, you do it with plus and you do it with minus. When you do negative 24 plus the square root of all this, so you run that through your calculator and you hit equals, you're going to get 0.992 or something like that. So 1 second. When you run it through with a minus, you're going to get 3.9 seconds. So that means the ball was over 20 between 1 and 3.9. So that is 2.9 seconds. Now, I didn't want to go over that, like run it through your calculator for you. You're just punching that in. The important part is recognize that you can move that 20 over there, and then you get a new quadratic that you can work with. All right, let's do this one. This is the hardest one. This is really hard, this question, and it leads directly into our next unit because it uses some quadratics, but then it asks you to do some stuff that maybe you're not too comfortable with. But let's have a look. So Louise is going to go for a bike ride. Take her 3 hours. She's going to go up the hill and down the hill. Now there's a typo in here. Her average speed is 35 kilometers per hour. And I don't know what that -1 is there, so it's gone. So her speed coming down the hill is 35k faster than her speed going up the hill. If the distance from the top of the bottom to the top of the hill is 40k, find Louise's average uphill and downhill speeds. Well, since we have distances and speeds, we're going to be doing some physics here. And we remember, distance equals speed times time, right? If I'm going 60 kilometers an hour speed for 3 hours, I've got 180 kilometers. So all I got to do is, knowing that, I'm going to work with this. So I also know that time equals distance divided by speed. And I know that speed equals distance divided by time. So I already know all that. I'm bringing that to the party. So let's have a look at this. Louisa is going to ride her bike. So she's going to go up the hill and down the hill. Yeah? So when she goes up the hill, she's got a distance, a speed, and a time, right? So what's her distance? How far does she go up the hill? Distance from the bottom to the top of the hill is 40. So she's going 40, right? I'm actually going to set this up differently. So her distance is 40, right? Her speed, we're going to set up uphill, downhill. So her distance is 40 up the hill. Her distance down the hill is also 40, right? What do I know about her speed? Do I know her speed? I don't know her speed. So her speed is going to have to get a letter. Her average speed down the hill is 35k faster than up the hill. So her up the hill speed, we don't know. It's speed, it's x. But her down the hill speed is that same speed plus 35, right? And we know that time is distance divided by speed. Well, there's her distance, 40, divided by her speed. The s looks like a 5, so I'm going to go ahead and make it x. 40 over x, that's her time up the hill, plus her time down the hill, 40 over x plus 35. And that's got to equal how many hours? 3. There is an equation, right? Because I have an x and it equals something. Now, what can I do to solve that? I need to know what x is. So I'm going to write it out. 40 over x plus 40 over x plus 35 equals 3. And I'm going to pause for a sec while you think about that. Remember, we know what to do if there's an x squared involved. I don't see an x squared there, so take a second and think. Okay, we're back. Now, remember, this is difficult. If you're having trouble, chill and just think. If I asked you to solve this, I'm going to come over here. 3/4 plus 5/7 equals x. If I wanted you to solve that, what would you have to do? Most of you hopefully would say you would need a common denominator. And that common denominator would be 28, right? What did you do here? You had to multiply that by 7. So what do you have to do to his partner? Multiply by 7. What do you have to do here? Multiply by 4. So what do you have to do here? Multiply by 4. See how it works? Now I've got a common denominator. So let's come back over to here. What would my common denominator be? Well, I did 4 times 7 to get 28. So wouldn't I do x, one denominator, times x plus 35? Right? This guy's denominator is 1. So, now that I've got that, this guy needed the x plus 35, right? And this guy needed the x. And this guy needed both of them, because he had nothing. So he needed x squared plus 35x, because that's what this is, x squared plus 35x. Now, what do I have? If I'm back over here, I had 21 plus 20, right? Did I care about the denominator anymore? No. So over here, I have 40x plus 35 times 40 is 1,200, and then 1,400. 35 times 40. 1,400 plus 1,400 plus 40x equals 3x squared plus 105x. And then I don't care about the denominator anymore, because I only care about finding x. Now, what do you see? There's an x squared, there's some x's, and there's a constant. Isn't that everything we need for a quadratic? Let's rewrite it. 3x squared, because I want my a to be positive, right? Now, x's, 40 and 40 is 80 plus 105. So I'm going to take away those two 40s, and I'm going to get plus 25x. And I'll bring that 1400 over here, minus 1400 equals y, right? Now all I got to do is find what x is. How do I solve for x there? I'll pause. There's a lot of methods. And we're back. How would you solve for x there? Well, I would hope that you would use the quadratic formula. So you would get negative 25 plus the square root of 25 squared minus 4 times 3 times negative 1400, all that over 2 times 3, or you would do negative 25 minus the square root of 25 squared minus 4 times 3 times negative 1400 over 2 times 3. And when you do those with your calculator, ignore this, that shouldn't be there. When you do that with your calculator, you're going to get two different answers, obviously. This first one, if I go to my calculator, slide it over here so you can see it, clear, negative 25 plus square root 25 squared minus 4 times 3 times negative 1400, close the brackets, divided by, now I'm just going to divide by 6 because 2 times 3 is 6. Oh, I screwed up here. Sorry, everyone. I got to remember to put brackets around the whole top because the 6 divides everything. Sorry about that. So bracket negative 25 plus square root 25 squared minus 4 times 3 times negative 1400, close brackets, divided by 6. 17.83. So x equaled 17.83. Or, and I'll do this one now. Oops, not that kind of bracket, silly me. Open bracket, negative 25 minus square root 25 squared minus 4 times 3 times negative 1400. Oops, missed the 1. Go back and check. 1400. Close brackets. Divided by 6. X equals negative 26.13. Now, x was a speed. How can I have a negative speed? So this is my answer. That's how fast she was going for x. So up the hill, she was going 17.83 kmh. Down the hill, she was going 17.83 plus 35, which is 52.83 kmh. And that's it. Now, you guys have a review to do. I can't remember exactly what pages it is. I'm going to pause it for a sec. It is pages 120 to 123. And I have that due for you on It's been posted. It is due. Classwork. Quadratics Review Summit due May 31st. Which is Sunday, May 31st. I want to see that in. Okay. That's it. We'll see you when we see you.